welcome to the video. Here's the problem we're looking at. We're purchasing cereal boxes at the store and we're hoping to get a secret decoder ring, and we're told that 21 out of the 44 boxes on the shelf have the ring. The other 23 have something else. So we're saying I'm going to buy 2 boxes. I'd like to get 2 secret decoder rings. What's the probability that if I buy 2 boxes, both will have the secret decoder ring? We can say, well, there's 21 out of 44 of them that have it. So about a half, 50% chance approximately that any given box will. Well, what's the probability that both of them will have it? So let's zero in on some keywords to do this calculation here. I see that word both, so I'm looking at an and probability. So the probability both boxes have the ring is the same as the probability that the first box has the ring and the second box has a ring. If we knew that the first box having a ring was independent of the second box having a ring, we could multiply here. And let me take a minute and talk about that in more depth, because that can be kind of a subtle and confusing point. On first glance, it might seem like, well, I'm choosing the boxes at random, so whether I pick right on the first shouldn't affect whether I pick right on the second. And that's true. The thing that keeps these events from being independent is that we have a finite number of boxes, 44 boxes. When I take one of those boxes off the shelf, that changes the number of boxes that have rings and the total number of boxes in a way that will significantly impact the probabilities I'm calculating. If there were, a million boxes on the shelf, well, taking one off isn't really going to change that fraction very much. But when there's 44 boxes, taking one off changes the fraction in our calculation a lot. So let's look at that. So we're not going to be able to consider these independent, because once I've chosen one box, depending on what type of box I chose, that's going to change what's left to be picked. So we're going to calculate this using conditional probability. We're going to say the probability that the first box has a ring and the second box has a ring is the probability that the first has a ring times the probability that the second has a ring given that the first had a ring. So let's do each of these out separately. The probability that the first has a ring. So we're picking that first box. We can think of a fraction here. The number of outcomes that would give us a ring is the number of boxes with rings. And they told us that's 21. My denominator is the total number of boxes. And the total number of boxes here, and I'm picking that first one, is 44. So the probability that I get a box with a ring, the first box I pick, is 21 out of 44. Now let's move to the second part of that calculation. The probability that the second box has a ring given that the first had a ring. So now these numbers are no longer going to tell us the number of boxes with rings. Now we need to think about, well, how many rings are left? So the number of boxes with rings left divided by the total number left. All right. So we used to have 21 boxes with rings, but we know that we got a ring in our first box. That's the thing we're conditioning on, so we're saying we know we got a ring in our first box. So now for our second pick, there's no longer 21 rings. There's only 20 rings left, 20 boxes with rings. So this numerator is going to be 20. For my denominator, there's no longer 44 boxes left. Now there's 43 boxes left. So my denominator there will be 43. So we can see how, because we know we got a ring on the first one, that changes the numbers that are left for the second one. So the events, can't really think of them as independent. So to do this calculation now, we're going to do 21 over 44 times 20 over 43. And they say we can give our answer as a decimal, so I'm not even going to try to multiply those out by hand. They would just be huge. So I'm going to do 21 times 20 divided by 44 times 43. When I do that out, oh, I didn't even keep it as a fraction. When I do that out, I've got 0.23308, so I'll round to 0.2331. It asks for a decimal correct to at least 3 decimal places, so we could just enter that 0.233 as our answer. So that would be the probability of getting 2 secret decoder rings when you buy 2 boxes of cereal. Oh, sorry, as I was putting this up, I realized there was a typo in my calculation. Let's go back and correct this. When you put this in your calculator, 21 times 20 over 44 times 43, 21 times 20 divided by 44 times 43, we should get not this number here. We should get, do that on your calculator, you should get 0.2219. So my apologies for that. I hope you weren't, oh, we're going to get 0.2, oh my goodness, can I write with a pen? 0.2219. So when we round to 3 decimal places, we're getting 0.222. So that would be the answer here, 0.222. So make sure you don't typo those when you put them in a calculator, like I did. All right.